Thank you so much. And also thank you a lot for the invitation and the possibility to have a speech here. And thank you for the audience for the interest in our technology. My name is Sebastian Heinz. I'm the CEO of High Performance Battery, and I'm happy to introduce you to our technology and to the benefits we see in the drop-in production for solid-state batteries. And I would like to guide you through this topic in 3 steps. The first one is who we are. The second one is what we do. And the third one, and this is the one you might be most interested in, is how we do it. Initially, who we are a battery technology developer. This is meant as it said, so we do not produce the batteries ourselves, but we develop the technology. And we do that based on a basic research of more than 30 years. We have filed for patents in 96 countries. We have at the moment 12 employees. We are growing. And we have a background of more than 300 private investors keeping us upright and enabling us to do the development of the technology. Our core business model is technology licensing. So we do that according to fields of application and geographies. For the stationary application bit, we do that on a non-exclusive basis for production, and we do that, and this will be outlined later on, also for the specific use of the solid-state electrolyte in other battery developments. The basic question we had, where we started off with the basic research of our inventor, was how to solve battery aging at its chemical root causes. And this was the key question to solve, because everyone of this audience knows well that battery aging especially happens due to the specific chemistry used. So the research question, how to solve those root causes, is leading us to the solution of this question. And that was a kind of a penicillium moment for us with a liquid electrolyte. And we developed the system turning out to be a solid-state battery. So it was not the intention to develop a solid-state battery, but to overcome the restrictions of battery aging. And this is a totally different starting point to come to a solid-state battery. And that is one of the reasons why we came up with a different procedure how to produce solid-state batteries, because we started off with a liquid precursor technology. So what we do is basically we develop solid-state batteries, and they are engineered to store renewable energy in a safer and more sustainable way. For us, it's really important to emphasize sustainability, because the demand increase we see in the oncoming years, it is so massive in all fields of application that it's really relevant to pay also attention to the sustainability issue and not just to the pricing issue. And we have a clear focus on stationary applications with our solid-state battery. This is due to the combination of the active materials of lithium iron phosphate versus graphite. And we do contribute to the EV battery improvement with our high-performance battery solid-state electrolyte, because this can also be used in different active materials. So that is why we can also support EV industry in inventing batteries with the superior use of the solid-state electrolyte. Our corporate DNA is very important, as I just outlined, because we are really looking for safety, we are looking for sustainability, for the conductivity issue, because that is also important for low temperature performance, for robustness and all of this. And we do not pay that much attention in terms of our own battery development, in terms of like real battery cell level, to specific and gravimetric volumetric energy, because that can be modified by changing the active materials. And due to the focus we have, lithium iron phosphate and graphite is the ideal mix also for stationary applications, at least to our personal point of view. So we are now coming to the interesting part, how we do this. We basically use the chances of chemistry, because the production of our solid-state electrolyte happens within the battery cell after adding a final liquid. And this is totally different from basically all the other approaches of producing solid-state electrolytes. We sum that up, and there has been quite a good research done by Fraunhofer Institute with the Solid-State Batteries Roadmap 2035 Plus, where they outline for different chemistries the problems they need to be overcome. And if you want to summarize this,